Hello, my dear students. Welcome back to IKSR chemistry classes. Here we are in lecture number 3 on the chapter Symmetry and Group Theory. In this video, we will discuss the reflection operation and plane of symmetry. If the reflection of all the atoms of a molecule through a plane passing through the molecule produces an orientation which is indistinguishable from the initial one. It is known as reflection operation and the plane is called plane of symmetry. Let us see it again. If the reflection of all the atoms of a molecule through a plane passing through the molecule produces an orientation which is indistinguishable from the initial one, it is known as reflection operation and the plane is called plane of symmetry. The plane of symmetry can be defined in simple words as follows. The hypothetical plane passing through the molecule which bisects the molecule into two equal halves which are just mirror images of each other is called plane of symmetry. The hypothetical plane passing through a molecule which bisects the molecule into two equal halves which are just mirror images of each other is called plane of symmetry. Let us illustrate it taking example of H2O molecule. This plane which bisects H-O H bond angle divides H2O molecule into two equal halves which are just mirror images of each other, and therefore this plane is nothing but a plane of symmetry. Symbol for plane of symmetry and reflection operation. The standard symbol for the plane of symmetry is sigma. The same symbol, that is sigma, is also used for the reflection operation. Types of plane of symmetry. There are three types of plane of symmetry. Vertical plane of symmetry, which is denoted by sigma v. Horizontal plane of symmetry, denoted by sigma h, and dihedral plane of symmetry which is denoted by sigma d. These are three types of plane of symmetry which will be discussed in detail. First of all, we will see the vertical plane of symmetry, that is sigma v. The plane of symmetry which is parallel to the principal axis, that is which contains the principal axis, is called vertical plane of symmetry. Let us recall principal axis of symmetry. The axis of symmetry of a molecule having the maximum order is called principal axis of symmetry. It is regarded as z-axis and it is kept in the vertical direction. Therefore, the plane of symmetry containing the principal axis will be in the vertical position and hence it is called vertical plane of symmetry. planes of symmetry in H2O molecule. This is H2O molecule. It is C2 axis of symmetry, and it is the principal axis for H2O molecule. It is regarded as Z axis and it is placed in the vertical position. H2O molecule has two planes of symmetry, and both of these pass through the principal axis, that is Z axis, and it is denoted by C2Z, and hence these two planes of symmetry of H2O molecule are nothing but sigma V. The first plane is sigma xz. It is the molecular plane. It contains x-axis and z-axis. Therefore, it is xz plane, and it is a plane of symmetry, and therefore it is denoted by sigma xz. This xz plane bisects H2O molecule into two equal halves. It bisects each of the hydrogen, oxygen and hydrogen atoms into two parts, this molecular plane. And another plane of symmetry is sigma yz. It bisects the angle between HOH. This plane contains y-axis and z-axis, and therefore it is YZ plane. This YZ plane bisects H2O molecule into two equal halves, which are just mirror images of each other as shown in the earlier slide, and therefore it is denoted by sigma YZ. Please note that these two planes of symmetry, sigma YZ and sigma XZ, contain the principal axis, that is Z axis, and therefore these plane of symmetry are nothing but sigma V. And now horizontal plane of symmetry, which is denoted by sigma H. The plane of symmetry which is perpendicular to the principal axis of symmetry is called horizontal plane of symmetry. The plane of symmetry which is perpendicular to the principal axis of symmetry is called horizontal plane of symmetry. The principal axis of symmetry is in the vertical position, and therefore the plane of symmetry perpendicular to it will be in the horizontal position, and hence it is known as horizontal plane of symmetry. Horizontal plane of symmetry in BCl3 molecule. BCl3 molecule has triangular planar shape. Z-axis is its principal axis of symmetry with order 3, that is, it is nothing but C3Z. The molecular plane, that is XY plane, bisects BCl3 molecule into two equal halves, and hence this XY plane is nothing but sigma H, horizontal plane of symmetry. It is BCl3 molecule having triangular planar shape. This axis, Z axis, is threefold axis of symmetry because the rotation of this molecule about this axis by 120 degree produces an indistinguishable orientation. It is the principal axis of symmetry of BCl3 molecule. It is denoted by C3Z. This molecular plane bisects BCl3 molecule into two equal halves, which are just mirror images of each other, and hence XY plane, that is the molecular plane of BCl3 molecule, is sigma xy, that is sigma h. It is in horizontal position. And the third type of plane of symmetry is dihedral plane of symmetry, which is denoted by sigma d. The plane of symmetry which bisects the angle between two C2 axes of symmetry is called the dihedral plane of symmetry. Please see it again. The plane of symmetry which bisects the angle between two C2 axes of symmetry is called the dihedral plane of symmetry. The dihedral plane of symmetry in CH4 molecule has been represented here. CH4 molecule has tetrahedral shape. It has three two-fold axis of symmetry, that is 3C2. It is CH4 molecule. Carbon atom is present at the body center of a cube, while hydrogen atoms are present at alternate corners of the cube. This is C2 axis of symmetry for CH4 molecule. The rotation of CH4 molecule about this axis by 180 degree produces an indistinguishable orientation, and hence this is C2. It passes through the centers of these two opposite faces of the cube. There is another C2, this one, which passes through the centers of this face and the center of the opposite face. There is another C2 also, which has not been represented in this figure. This C2 passes through the center of this face and the center of this face. It will also be C2. It is C2. There are three C2. Now this plane bisects CH4 molecule into two equal halves which are just mirror images of each other, and this plane bisects the angle between two C2 axes, and therefore this plane of symmetry is nothing but dihedral plane of symmetry. This plane which bisects CH4 molecule into two equal halves and which bisects the angle between two C2 axes of symmetry is nothing but dihedral plane of symmetry, and it is denoted by sigma d. Now reflection operation, which has been defined earlier. During reflection operation, the laws of reflection of light are obeyed, and the plane of symmetry acts as two-way mirror, whose both the sides are reflectory. During reflection operation, the laws of reflection of light are obeyed, and the plane of symmetry acts as two-way mirror whose both the sides are reflectory. During reflection operation, each atom of the molecule is moved towards the plane of symmetry in perpendicular direction, and then the atom is moved in the same direction by the same distance to the opposite side as illustrated below. This is H2O molecule having two planes of symmetry, sigma xz and sigma yz. This is yz plane, which is denoted by sigma yz. This plane bisects the angle H dash OH. If H2O molecule is reflected through this YZ plane, it will be called sigma YZ operation. During this operation, H atom is moved towards the plane of symmetry and then in the same direction by the same distance in the opposite side. As a result, the image of this H atom will be obtained here. This H atom will shift to this position and red colored H dash atom will move to this position as shown here. This is orientation number 2. H dash red colored atom has shifted to this side and the image of this H atom will be obtained here. Orientations 1 and 2 are indistinguishable and hence it is a symmetry operation. It is known as reflection operation or sigma by z operation. Let us apply sigma yz operation on orientation number 2. As a result, the reflection of this H dash atom will be obtained here and the reflection of image of this H atom will be obtained here as in the orientation number 3. Orientation 2 and 3 are also indistinguishable and hence it is a reflection operation or sigma by z operation. Orientations 1 and 3 are identical. This red colored H dash atom is present on the left hand side and in orientation 3 also H dash atom is present on the left hand side. On moving from 1 to 3 orientation, we have applied sigma yz operation twice and it will be equal to sigma yz square. And since 1 and 3 are identical operations, sigma yz square is nothing but identity operation. It means if reflection operation is applied on a molecule one by one twice, it is nothing but identity operation. Number of symmetry operations about a plane of symmetry. Only one symmetry operation, that is sigma, can be carried out about a plane of symmetry as illustrated below. As we have seen earlier that if sigma operation is applied on a molecule twice, that is sigma square is nothing but identity operation. Sigma 3 will be equal to sigma square into sigma and sigma square is nothing but identity operation, and if identity operation and reflection operation are multiplied, it will be equal to sigma. Sigma to the power 3 is equal to sigma, sigma to the power 2 is equal to E. Sigma to the power 4 will be equal to sigma square into sigma square, that is E into E, and it will be equal to E. For example, 1 into 1 is equal to 1. In general, we can say that sigma to the power n is equal to E if n is even. Sigma to the power 2 is equal to E, sigma to the power 4 is equal to E. It means if sigma to the power n where n is even, its result will be identity operation. On the other hand, sigma to the power n will be equal to sigma if n is odd. Thus, only one symmetry operation, sigma, can be carried out on a molecule about a plane of symmetry. Now, the time for self-assessment. If you have learned, if you have understood the concepts discussed in this video, you will be able to answer these questions. Identify the planes of symmetry, their number 1 to 3, and nature, whether sigma v, sigma h, sigma d, or simply sigma in following molecules. You have to identify the planes of symmetry, their number, and nature in the following molecules: SF4, CO2, SO2, BCl3, HOCl, and NH2Cl. It is hypochlorous acid, and NH2Cl is nothing but chloramine. And second question, apply sigma H operation on PCl5 molecule, representing its chlorine atoms as Cl, Cl dash, Cl double dash, Cl triple dash, and Cl dash 4 times. You have to apply sigma H operation on PCl5 molecule, representing its chlorine atoms as follows. Thank you for watching the video with concentration. Please like and share it. If you have not subscribed my channel yet, please subscribe it so that you may get information regarding my new videos in time. Thank you again.